All right, so I'm just gonna go through the whole thing. Yes.
I'm gonna review sheet.
Yeah.
Oh, you can have one. You can have some.
If I have enough. Yeah. I do.
Actually, I'd rather it's fine. You want to get a paper? Oh, I feel like talking all this.
You guys are on the All right. Oh, sign it. Alrighty. So starting with number 1, you know 3 factoring methods: dots, sum and product, and GCF. Which of those 3 am I using on number 1? Irene.
Sum and product.
Sum and product. You know you have to use sum and product because that's the only method that can handle a trinomial right now that you're aware of. So what is the sum for this?
5.
5. Good. What is your name?
Sophia.
Sophia. Hi, Sophia. What is the product?
-14.
-14. Why is Sophia, who's not my student, standing my students up right now? Let's go. What is the pair that multiplies to -14 and adds to 5? We're going into y equals, and we're plugging in -14 divided by x. We're leaving x plus y1 and y2. Ryan, what's the pair?
-2 and 7.
-2 and 7. Very good. Now, what is my next step for factoring this? Go ahead, Ryan.
Do 2x squared. And you can do either plus or minus 2x or plus 7x, doesn't matter. Plus 7x. And then you do minus 7.
Good. Now I'm grouping these together. First 2 terms, and I'm finding the greatest common factor. What's the greatest common factor of 2x squared minus 2x? Elizabeth. 2x. Good. What's left over in the parentheses when I pull the 2x out? Kayla.
X plus minus 2.
X minus, not 2 though, because if I do,
How do you find the greatest common factor?
greatest common factor. So you can find the GCF, well, GCF of 2 and 2, if it's the same number, it's always that number. If it's, of course, it's the same for this too. If it's 2 and 18, you can do it in your calculator. Math, right arrow, 9. And then you plug in 2, 18. The comma's right above the 7. It will give you the greatest common factor. The greatest common factor is the biggest number that's a factor of both of them. So the way I say to do that is, let's pretend we're finding it for 2 and 14. Take the smaller number, because that usually has less factors, and name the factors. The only pair of numbers that multiplies to 2 is 1 and 2. Take the largest one, because you're looking for the greatest common factor. Check if it goes into the other thing. If it goes into 14, it's the greatest common factor. In terms of variables, it's the one with the lower power. Between x squared and x has a lower power. Can only be an x or a variable if they both have a variable in common. So greatest common factor. 7x minus 7. 7 doesn't have an x, so there's no x in this GCF. 7x minus 7, the GCF is 7, because they're the same number. What goes in this second bubble here?
X minus 1.
Good. Steal it from the first bubble, because they always have to match. Then your GCF, your answer is the bubble they share, and then everything else. Doesn't matter if you flip-flop the order of these. It's the same thing. Questions about number 1? Okay. Number 2 is asking about the average rate of change. So it says the table shows the year and the number of households in a building that had solar panels installed. Which interval of time was the average rate of change the largest? So another word for average rate of change is change in y over change in x. Or y2 minus y1 over x2 minus x1. The weird thing about this problem is years are on the bottom. Time is always your x. So x is on the bottom and y is on the top. That's not normal. Usually X is on the top. So you need to plug in all of these different values. So for 2002 to 2004, I'm using these 2 points. Subtracting the Y's, remember these are the Y's. So 23 minus 11 over 2004 minus 2002, which you can just plug right into your calculator. So this is 12 over 2, which is 6. Then you're going to do it for all the rest of the choices. 2003 to 2005, you're using these 2 points. So when I plug that in, I get 33 minus 16 over 2005 minus 2003, which is 17 over 2, which is 8.5. And I'm just going to kind of cheat and show you the work for this. They're all divided by 2 because when you subtract all of these intervals, you get 2. So that's why I just didn't show that. But all of the intervals are here on the answer key. So we did this one. No, we didn't. I'm lying. We did this one and we did this one. These are the other 2. You have to figure out which one was the biggest or the largest. The biggest was 9.5. So that was 2004 to 2006, which was choice 3. That one's a little long. Number 3, in a sequence, the first term is 6 and the common difference is 2. Find the 6th term of the sequence. So the first term is 6. You need to find the 6th term. So if this is the first term in the list, here's the second, third, fourth, fifth, 6th, and then I just fill in these blanks. The common difference is 2. That means you're adding 2 each time to go from one term to the next. Plus 2. Plus 2, plus 2. So each time you're adding 2. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. 12 plus 2 is 14. 14 plus 2 is 16. So 16 is the 6th term. Questions? Okay. Number 4, solve the inequality. So you need to get all of your x's on one side and all of your numbers on one side. So the first thing I did was I moved the 5 over, and I have negative 4 over 5x is greater than x plus 30. Then you have to get all of your x's on one side. Yes, Ryan?
For the last one, when you count 6, do you start with the 6? And
This is the first term. So this is 1, 2, 3, 4, 5, 6. So then you move this x over. There's an imaginary 1 in front of it. So I'm moving 1x over. Negative 4 over 5x minus 1x. You can just do in your calculator. Negative 4 over 5 minus 1 is negative 9 over 5. Is greater than 30. And then you have to divide by the negative 9 over 5 on both sides.
Don't you have to flip the sign? You flip it when you divide by a negative.
Yes. When you divide by a negative, you flip the sign. So then you're doing 30 and you're dividing by this, which is negative 50 over 3. And yes, I flipped the sign because I divided by a negative. All right, good. Questions about page 1? Bless you. Okay. Number 5, a population that initially has 20 birds approximately halves every 10 years. Which graph represents this population growth? Well, it initially has 20 birds. Initially is a word that represents the starting value or the y-intercept. So the y-intercept has to be 20. So right off the bat, I'm getting rid of choice 1. It doesn't have 20 as a y-intercept. The next thing you're looking at, if something is halving or doubling or tripling or quadrupling, it is not increasing in a linear manner, okay? It's increasing exponentially or it's decreasing exponentially. In this situation, it's halving, so it's going down each time. That's not linear. Remember, linear has a constant rate of change. That's exponential. These are exponential functions. So this is not possible because it's linear. Has to have a y-intercept of 20. Both of these have that. It's halving, so that means it's going down. It's decreasing. This is the only graph here that's decreasing. So it's choice 3. If it said it was doubling or tripling, it could be this graph because that graph starts at 20 and it's exponentially growing. But this is saying, like, every year there's 3 more birds. That's a constant rate of change. Every year it's doubling means there was 20 birds, then there was 40 birds, then there was 80 birds. That's not adding the same amount each time. It's multiplying by the same amount each time. So that one's 3. Number 6 was asking which one is a linear function. So you have to check and see, again, linear, constant rate of change, going up or down by the same amount each time. So here, to get from 1 to -4, I subtracted 3. Then I subtracted 1. Then I added 9. That's not linear. I'm not adding or subtracting the same amount each time. For B, I subtracted 3, then I subtracted 1. Already, that's not linear. It's not adding the same amount each time. Here, I subtracted 3, then I subtracted 3 again. We're looking good, but then I added 3. So I'm subtracting the same amount, but then I start adding. Can't do that. Here, I added 2, then I added 2 again, then I added 2 again. So that's linear because it has a constant rate of change, adding the same amount each time. Number 7. A student invests $1,000 for 6 years in a savings account that earns 3% interest per year. No further deposits or withdrawals are made during this time. Write a statement that yields the correct balance in the account at the end of 3 years. So you have to look at each piece of information here. 3 years. Whoops, I don't want that color. 3 years is talking about the amount of time. So that's telling you that the t, or the time, is equal to 3. Here's your formula you're using for this. Whatever the amount is after said amount of time equals the initial amount you invested times 1, always 1 because that represents 100%. This is actually plus or minus. Plus or minus, depending on if you're increasing or decreasing, your rate, which is your percent in decimal form, all to the power of time. So 1,000 is your initial amount that you invested. Always have a 1. Then you have to decide, am I increasing or am I decreasing? I'm earning interest. When I'm earning interest, my amount is going up. So I'm adding, and then it's 3%. Who can tell me what 3% is as a decimal? 0.03. Good, Irene. 0.03 is my R.
Do you move it twice to the left?
Yep, twice to the left, or just plug it in the calculator and divide it by 100. Whatever the percent is. 0.03. And then T is your time, your exponent. They're talking about 3 years. I don't think they're asking you how much it is. I think it just said write a statement. Yeah. You don't have to tell me how much it is. You just have to tell me what the equation is. Number 8. Number 8 says factor. So you need to use one of your 3 factoring methods. Why can't I use sum and product on number 8? Kayla?
Doesn't have 3 terms.
Doesn't have 3 terms, so I can't use sum and product. I also can't use GCF because there is no GCF other than 1. So there would be no point because it would end up looking like 1 times 36x squared minus 49y squared, which didn't change the problem at all, except brought a 1 out in front. So this is using dots. All of these things are perfect squares. Dot stands for difference of 2 squares. It has to be a difference. I have subtraction, so that works. O just means of, we don't care about it. T stands for 2. There's 2 terms, so that works. S stands for perfect square. This is what is on your Post-it. All of the first 15 perfect squares, and anything with an even power is a perfect square. So perfect square is 36 and 49, those are 6 squared and 7 squared. X squared and Y squared both have an even power, so they're both perfect squares. So I'm using dots. When I'm setting up dots, setting up a plus and a minus in my parentheses, 36x squared, I'm taking the square root of that. If you're not sure what the square root of 36 is, second x squared in your calculator, 36, it will tell you the square root is 6. And then the square root of x squared is x. Remember, we just divide the power by 2. 2 divided by 2 is 1. So the new power is 1. 6x, 6x. Same thing for the 49y squared. Square root of 49 is 7. Square root of y squared is y. So it's 6x plus 7y, 6x minus 7y. When you're doing dots, you're always going to have the same exact bubble. The only difference is the sign. Questions on page 2. Okay. Number 9. During a recent snowstorm, Joe noted that there were 7 inches of snow on the ground at 12 o'clock p.m. and 12 inches of snow on the ground at 7 o'clock p.m. If he were to graph these data, what does the slope of the line connecting these 2 points represent in the context of the problem? So remember, we're talking about slope, which is y2 minus y1 over x2 minus x1, also known as change in y over change in x. Now, as I said earlier, x is always represented by what?
Time.
Time. So your x's, the unit on that is going to be time. The other thing the problem is talking about other than time is snow. So it's going to be the amount of snow for the y's. Snow is being calculated in inches. It might be feet, it might be inches, it might be centimeters. I don't know. Here, it's inches. Time is going by hours. They're talking about 7 p.m. and 12 p.m. The division sign in between inches and hours, what word does that represent? Per. So it's inches per hour of snow, if you wanted to get fancy. Inches per hour is good. 10, Gail deposited $9,000 in an account at the Levittown Bank, earning 2.7% interest. She made no deposits or withdrawals. Write an equation that can be used to find B, her account balance after T years. Again, same formula that we used before for exponential growth or decay, depending. My initial amount I'm depositing is $9,000. Times, always the 1. Again, I'm earning interest. I'm earning it. So I'm increasing by whatever that is. I need to change my percent. What is it? 0.027, good. 2.7 as a percent is 0.027. Again, you could divide by 100 in your calculator. And then it's not telling you how much time, it's just telling you T years. So we're leaving T. And all of that is going to be equal to her account balance, which is B. And again, you don't have to plug anything in. You can just leave it as the equation. Number 11 is definitely going to take some time on the test, so make sure you leave yourself time for this. And it's also number 11 on the test, just so you know. Lauren and Nicole went to the supermarket together, socially distant and wearing their mask. Lauren bought 10 boxes of plastic spoons and 12 boxes of plastic forks for a total cost of $30.38. Nicole bought 5 boxes of plastic spoons and 9 boxes of plastic forks for a total of $19.66. Find the cost of 1 box of spoons and 1 box of forks. So I use, actually, I'm going to change it when I do this with you now to X and Y, because I don't like using S, because it kind of looks like a 5. So X is going to be spoons, and Y is going to be forks. So you need to write an equation for each person. So Lauren, her equation is going to be what?
10x plus 12x equals 30.38.
Very good. 10x plus 12y equals 30.38. Then the other person is Nicole. What is Nicole's equation, Elizabeth?
5x plus 9x equals 66.
Good. So those are my two equations. This is a system of equations that I'm solving because it has more than one equation. I'm trying to find the point that satisfies both. So in order to solve this, you have two options. You can use substitution or you can use elimination. This is set up nicely for elimination because of the coefficients in front of the x's and the y's. If you wanted to do substitution, you could. It's just going to look ugly with fractions. So I recommend doing elimination. When you're doing elimination, you need to get rid of one variable. So you could do the y's if you want. The x's are a little easier because there's something that's kind of jumping out at you with the 10 and the 5. What can I multiply this bottom equation by to get rid of the x's? Kayla?
2.
Okay, but that's not going to get rid of them.
Negative.
-2. Because if I multiply by -2, this will be negative 10x, and then these will cancel out when I add it together. So you're going to leave the top equation alone. And then you're going to multiply the bottom equation by 2, including the answer. And then you're going to add them together. So the x's cancel. 12y minus 18y is -6y. And then you're adding 30.38 plus -39.32, -8.94. Then I need to get y by itself, so I'm dividing both sides by 6. Sorry, -6. And you get 1.49. If I got a negative number for this answer, why would I know that it's wrong? Ryan?
Because in money you can't add negative.
It's money, so I can't have -149 as my price. It would have to be a positive cost. So that's my y value. As long as you tell me in the beginning that y equals forks, you don't have to write a sentence explaining what that means, but you have to remember that you have to tell me what your variables mean, which you should do that anyway. Once you have that number, you have to plug that number back into one of the original equations and solve for the other number. So I'm going to plug it into the first one, 10x plus 12y equals 30.38, and then solve. And 12 times 149 is 17.88. And then you're subtracting 17.88. And I'm just going to jump ahead. It's 12.5, divide both sides by 10, 1.25 is your y. So your price for the box of spoons is $1. Sorry, you're right. $1.25, and the price for forks is $1.49. If you don't do this, you have to write a sentence saying that. So choose one or the other. I would just recommend this. It's easier. Questions about 11? Okay, the last one is the factoring question. It looks exactly like this on the test. There's 3 parts. And you know 3 factoring methods. Bye, Kayla. Have a good day. You know 3 factoring methods. So each one is going to be for one of the factoring methods. You know sum and product, you know GCF, and you know dots. Sum and product. Which one is sum and product? Irene.
The first one.
Sum and product, because it has 3 terms. Then you have to decide between GCF and dots for this. Yes, Elizabeth?
C is dots.
C is dots because everything on there is on your Post-it. 4, 169, and it's to an even power. And then also it's a difference. It's being subtracted, and there's 2 terms. And then B, yes, Sophia.
I don't get the dots one.
How to do it?
Like how you know it's dots.
Because it has to be a difference. So you have to be being subtracted. So this can't be it because we're adding. Here we're subtracting. We don't care. T is for 2 terms, so it has to only have 2 terms. This has 3, so I wouldn't be able to use it. S stands for perfect square. 9 is a perfect square, 54 is not, so I wouldn't be able to use dots on this. 4 and 169, both perfect squares. X squared is a perfect square. Any X or Y or variable raised to an even power is a perfect square. As long as it's
169 a perfect square.
So in your calculator, second X squared, 169, 13 squared is 169. I gave my kids a Post-it and I let them write the first 15 perfect squares on it because I know you guys aren't really familiar with that. It will come with time. When you do higher level math, you'll know them. But for now, just recognizing them, I don't really care so much about them memorizing them. That's why I'm just giving them the Post-it. I don't know what she's doing, but that's how you do that. So just check if it's a perfect square in your calculator. If it's like another one you might not know is second X squared 196 is also a perfect square. Check it in your calculator. If you get a nice number that's not a decimal, it's a perfect square. Okay, dots, sum and product, and this one's GCF. So, sum and product. What's the sum for A? You can just say it.
-11.
What's the product?
24.
Good. First times last is the product. 6 times 4, sum is in the middle. Find the pair that multiplies to 24 and adds to -11.
-8 and -3.
-8 and -3, good. So now I'm rewriting. 6x squared minus 8x minus 3x plus 4. I am grouping first 2 together. 6x squared minus 8x. What's the GCF, Elizabeth? 2x, excellent. Left over is what?
X. Oh, 3x.
3x. Carry down the minus.
4.
4. Good. Carry down the sign in between these two. The GCF of 3x and 4.
1.
1. What goes in the parentheses? 3x minus 4 has to match. Good.
If it was like -3x, 3x plus minus 4, would you carry down the negative? Like I'm confused.
Has to match this one. So whatever's going on here is going on here.
It's not the same as wrong.
Right. Yes, correct. If it's not the same as this bubble, you did something wrong. So when I distribute this, -1, it has to equal whatever is going on up here. So if it was minus and you put a plus here, that would be right. Because when I distribute this, minus times plus is minus. But since this is a plus, when I distribute this -1, negative times negative is positive. So that works. I wouldn't worry so much about this sign. You're not always bringing this sign down. That's why I tell them, whatever this bubble is, just copy it. Because it's going to be the same.
No, I'm saying you know how you put you drop the negative?
This,
Would you drop if it was -4, would you put that negative and it was
yes,
positive?
you always drop this sign.
Oh, no.
This you do not always drop. You always drop this and this, not the last one. What is the first bubble of my final answer? Andrew, what is it? First bubble of the final answer for this. Good. 3x minus 4, the one they share. Bless you. What is the second bubble of my final answer, Ryan?
2x minus 1.
2x minus 1. Good. Questions about that? Okay. Next one is GCF. You have to find the GCF of 9 and 54. Calculator, math, right arrow, 9. 9, 54. GCF is 9. Why is there no x included in my GCF for this? Elizabeth.
Because the 54 didn't come back.
Good, 54 doesn't have an x, so it's the greatest common factor. They don't have an x in common. So that's not part of my GCF. What goes inside the parentheses when I pull the 9 out? Elizabeth? X plus 6. If you're not sure, 9 times what gives you 54, divide it by the GCF. 54 divided by 9 is 6. Then the last one, dots. Start out dots by writing your 2 pairs of parentheses. One with a plus, one with a minus. Take the square root, 4x squared. What's the square root of that?
2x.
2x. Goes in the first spot for both. And then the square root of 169, I think we did that before, is 13. Also on your Post-it, you have the first 15 perfect squares. If you see 169 on it, count which number that is if you don't want to do it in your calculator. Easier to just do it in your calculator.
Yeah.